This conference will now be recorded.
Yeah, usually, when if there is any cancellation of sessions, I'll definitely update early itself, a little early. But usually, I don't try to cancel. Probably when there is some issue, a genuine issue, then only I try to miss the sessions. Otherwise, I don't like having gap in between the sessions. Okay, so that is one thing. So what I request is, if at all, if I am not there for at least 10 to 15 minutes, just wait for at least more than 15 to 20 minutes. Still, if this doesn't turn up, then maybe you can log out, but just wait for some time. Okay, anyhow, you can just log in and just see there. Okay, so now this is, anyhow, we done it in the last session with multiple parameters for this higher order function. That is a good session. Still, I feel one of the best sessions we had so far. So this is a higher order function with multiple parameters, right? So with multiple parameters. Okay, let it be there now. Now let's move to this. Switch to the next one. This is called function composition. Okay. Somebody asked me a question in the last class, like how higher order functions are useful, and I tried to answer your question, and also I told you we'll talk about it when we come to the point of collections. Definitely, when we talk about map, flat map, there are many more like that functions. Okay. So there are many iterators that way. When we go to that point, definitely I'll clearly relate what we are learning here with the existing built-in functions as well, so that you get a bigger picture. Still, definitely, we will see the pros and cons, like the other benefits of using higher order functions. One thing in Scala is these are called first-class citizens in Scala. As per the Scala author, functions are called first-class citizens. Means in most of the cases, Scala dependent more on functions. That is one thing you have to remember. And higher order functions, definitely, it is a catchy kind of concept here. It's a very good concept in Scala, because when you go to the Spark, or because this is more for a background for Spark for us. When you go there, you see a lot of built-in functions, and most of those functions take parameter as a function itself, and they return sometimes a function as a value, not just a value type as value. The function itself will be value. Like that, this Scala is designed like that. And also one more thing, what we didn't discuss is this is developed from Java. But when you look at the code of Java and Scala, there is a lot of difference. There's a lot of optimization happened in Scala. Even when you look at Python also, when you look at Python and Scala also, Python is simple, but Scala is much more optimized than Scala, and it is highly performance oriented. But the only problem always with Scala is we don't have proper community support. That is one thing what I observe usually in the projects or in the websites, or whatever. We have very basic things. Only very few people, handful of people are like that, are really good with Scala. Now, why I'm telling all this is so that you can concentrate more on your Scala, and it is definitely going to help you someday. So that is fine. Next one. Let me switch to my discussion. Function composition. What is this function composition? It's something not too difficult. If you look at this, it's simple. Means you see here, it's like passing a function call to another function. That is what function composition is. We have seen, what is that? Passing function as a parameter to another function. That is one thing we have observed. This is again a little different here. What is that we are doing is we are directly passing the function call itself as a parameter to another function call. This is composition. Maybe you can ask me a question. What is that? You have explained higher order functions in the last class, and you told us what is that? In higher order functions, we pass function as a parameter to another function. Correct. In the column, right? But now in this, we are also passing function as a parameter. Then what is the difference between these two? Then my answer is when you look at higher order functions, we have just passed function name as a parameter. And what did we do? Here, if you look at this, see the difference. We have passed function name as parameter, and we are not passing any color here. You see, when I put parenthesis, it becomes a color. And now, if I remove parenthesis, it's just a value here. It's more or less like a value. When I put like this, it becomes a color again. And if I can pass an argument depends on the signature of the function, or depends on the syntax of this function. So if you do like this, it is composition. And if you look at this, this is so easy to understand. There is nothing complex here. Look at this here. What is the difference you find here? You are seeing a whole function call as a parameter to another function call. Look at this. And this is what simple we can say. So that's what composition is. And this is there even in C language, C++, Java, even C#. We can do this anywhere. This concept existed from from the very beginning. But higher order functions, something I'm sure I didn't see in C. I'm not sure, but I don't conclude it. But I didn't see in C such thing. I didn't see until at least Java 1.7 such thing. But I'm seeing only, I had seen that in Scala. I don't know about 1.8 because even though the concepts are somewhat same between 1.7 and 8, I didn't explore too much of 1.8. By that time, I moved to Python and then I switched to BigData. So I was there initially for 4 years in Java. That's why I cannot confirm about higher order functions, the existence of higher order functions in other languages, but that is there in Scala, and I hope that is there in Python. I hope. Okay. So, but now this is there everywhere. This is there everywhere. It's there in C. It's there in C++, Java, C#, Python. This concept is there everywhere. But higher order is not sure. That is what I want to again give a clarity to all of you. Now, I think there is nothing difficult here. To understand this, you don't need to be a pro here, or you don't need to be a charm here. Okay, just basic idea about functions. What is that? You are just seeing two functions, multiply by 2 and add by 2. And if you look at it, that's a very basic function. Okay, we're just doing addition of a number with 2, then addition of and then product of a number with 2. That's all. That's what we are doing. And if you look at this, what I'm doing, I'm calling multiply by 2 first, and to that I am passing parameter as what is that? My addition. How this work here? How this work is simple. When you write a code like this is actually composition. This is composition. Even inside this, I can call some sum of. I can call something like sum of sum 20. We don't have that function, but I'm just giving you an idea. I can do this again. So this thing can happen. That is not something too difficult to understand. This can keep going like this. Okay. Anyhow, I am removing sub here because I didn't have sub for now. Okay. Just pass any value of your choice. Now, what is the execution flow here? How this work here? So first time, it will call multiply by 2. Before calling multiply by 2, this has to be executed. Something in the parenthesis, this must execute. So when this must execute, what happens? First, this is a function call, and this will make a call to add. Control comes here, and then that one parameter, whatever is there with the add, that is passed to this, and then addition is happened. When you declare something like this in a Python function, what happens, guys? Right? This is serving two things here. It serves two. It is like two birds in one shot. What is it doing? we are doing addition here. At the same time, we are returning this value. We are doing two things in one shot. Okay. And some traditional learners or traditional programmers, you might ask me a question. There is no return type, and all of you are very clear in Python, sorry, in Scala, you don't need to use a return keyword. When you just declare something like that, what happens, what happens, gentlemen? This is the returning a value of itself. Okay, I think I had given a clear explanation in the previous session somewhere. Okay, now what happens is this 10, we are passing 10 to this add, that 2 is added to 10 and it becomes 12, and that is sent as a value to this color. So in place of this color, this 12 gets substituted. Now what happens? Again, multiply by 2 is called. First this is called, the inner parameter is called, and then multiply by 2 is called. Okay, now what happens? It will come here and it will bring that 12, because add 2 has returned 12 to us. That 12 2 is passed as a parameter to multiply by 2, and now 12 into 2 we get 24. That is written back, and that is assigned to this result. When you print it, you get 24. And that is what we should see in the result. So what do you do right now? Why don't you test this code, all of you? Why don't you test this? Can you please test this code? Test it yourself. I am testing myself. You test yourself. All right. Give me a minute. I think it stuck. Yep. Now it's fine. Okay. Save this. If you want, you can make changes to the code, but I would like to continue with the same. But only the point is, I should get my output as what? I should get 24. That's what the point is. Now right click, and you can say run as Scala application. We got it 24. Perfect. You understand, right? Okay. Test it, all of you. Just take a minute and test. So this is composition. Okay. All of you are clear now about composition? Function composition. Next topic. Okay. Anyhow, this code is with us. Now the another important topic in functions. Okay. What is this? Lambda functions. Okay. And this is something we need to understand clearly, because in many places in Scala you find lambda functions, even in Python also. Lambdas are the most powerful functions. It's like, if you are from C++, I'm not confusing you, just giving you some idea. If you think you are from C++, you take it, otherwise ignore it. There is something called inline functions, you remember, right? In a way, I can tell these lambdas are more or less like inline functions in C++ and like macros in C language, if you want to compare with other languages. And of course, Java came from C, But of course, we don't have inline functions in Java, but from 1.8 version, still 1.7, we don't have lambdas in Java. But after this Python and Scala having all this, these lambdas were introduced in Java as well from 1.8, if I'm not. But if you go to the Java, most scripting languages also have a lambda concept. I observe that there, and it's nothing. What is the lambda here means? It's simple, guys. A function without any name. That is what we call lambda, and we call it as anonymous functions. And these are very useful if you want to pass a function as a parameter to another function. And we see examples. Might be for now, just listen, just observe. Okay, I will again remind this. We'll come to again a deeper discussion point to this. I'll remind. Don't think I am going to skip it. When I say something, we'll discuss. We'll discuss. So anonymous function is nothing. I told you, right? It's a function without any name. And then if you want to just a single line of code, a single line, simple logic in one line, okay, then lambdas are the best preferred functions. You cannot write so many lines of code with lambdas, but if you want to just optimize a code and if you want to just implement it in a single line, one line, then you go for lambdas. One challenging thing here is many people talk so much about this Python and Scala. I hear sometimes long back now from some people, 100 lines in Java is one line in Python. I don't know how it becomes, but people tell this. And this is possible in Python. But that is an exaggeration. Not like 100 lines become one line, but 100 lines might become 10 to 15 lines. We can agree for that. Okay, that is one thing. Second thing, even in Scala, the same is applicable. It is much more optimized. Okay, but the point is, remember always, when you are able to optimize a code of suppose 20 lines to some 3-4 lines, don't think that is so simple. Writing a line of code is okay, fine. It appears to be very romantic for us, but the point is optimization needs lot of expertization. People don't know this. It is easy to write a algorithm in 20 lines or 30 lines, and if somebody asks us to write the same algorithm in 5 to 10 lines, we have to think a lot about it. Okay, and that is the best thing you have to practice from now on, even you or me or anyone, because when your experience goes, when you are becoming an architect, our thought process should be, we have to focus more on how can we optimize a code. That is very important, because even my experience is going now, I am thinking in that lines only, because as an architect our aim is tuning. What we do as an architect is code will be anyhow, the developers will be doing that. Our responsibility is to tune the code and to look at the performance of code and optimize the code. This is our challenging things. Okay, so and bringing that thing into the picture here, lambdas is something where you don't have so many lines, you have just a single line here. Again, when you are bringing something to a single line, you have to have a sound knowledge on that, and you should be expert on that. And that we can do with the lambdas. Very useful, and you can see these lambdas in many places. Got it right? Now the point is, why I took some time to explain this importance is we have to think in that direction. So now again, and one more disadvantage with lambdas is, of course, what is that? You don't want to reuse it later. What is that? Lambdas are like instant functions where you can use them then and there itself, and you cannot reuse like normal functions. Keep this point in mind. You can add these points in your notes as well. Okay, so we cannot reuse lambdas like other functions, like normal functions. But what we can do here, it's like an instant function where we can use something then and there itself, and which increases what is that it will add lot of value to that logic or something like that. That is one important thing. And how do you create anonymous functions in Scala? Okay, we use arrow mark here. That is what we call racket. The technical name of arrow mark, we call it as rocket. Or what is that? Underscores. And this is a wild card in Scala. Using these two, we create what? Anonymous functions. Either rocket by applying rocket or by applying underscore. Observe these two, understand these two carefully. Is this fine for all of you? What is that? We are not using something like see, that is a parameter, man, Bharat. When you talk about it, see, when you are passing it to a function, it is different. Function needs a parameter, but making it as a lambda is different. Okay, we'll talk about it. These two are two different things. Let's not get confused with mixing those two here. Okay, I think Bharat, you are asking me a question. I am answering your question. So whatever you are saying, f colon int the racket any value, it's more or like it's more or like declaring a parameter. And what is that? This rocket here is more or less what is this here? It's a separator here between this return type and between these parameters. But whatever we are talking here is what? We are not talking as a parameter. We are talking about how this lambda function exactly look like. That is what the discussion is. And then later on we'll talk about it. Okay, so this is what the first primary basic things we need to understand. We should apply either racket or underscore here to create a lambda. Then we'll see a few very simple examples for now. So this is the first one. So if you look at this whole statement itself is something like writing a one function. In one line, you can see we are able to write one function itself. Here there is a function. You might see look like this, something like a simple statement, but to be honest, this is a function here. And this is something like this. Let me elaborate it. Let me take this code from here. And let me do a little postmortem so that what happens is we get a bigger picture. Okay, I'm removing all this. And here, if you see one more thing here, maybe you can observe here carefully what I have. You didn't see. What is that? This is actually the composition, right? And what we are doing here, these functions are declared outside the where this is declared. This is a you look at this. This is outside your main, isn't it or not? Can you see this? Is it inside main or outside main? Inside main. Sorry, outside main. Okay. Now, if you look at this code, look at this code. See, I have two functions here. To be honest, how many functions are here? We have two functions. This is a lambda, and this is also a lambda. Can you see that? Both are lambdas. Means I have two functions. It's like this. And here, this is optimized, and this is more optimized. We'll come, it's like let's backtrack this. Let's backtrack. Let's come from bigger level to small level. And you see the shrinking of code level by level. Then you get a perfect picture so that you don't have any confusion. Suppose I'm doing sum of two numbers, gentlemen. What I'm doing? I'm doing sum of two numbers. How do I do? Let's what is that? Start it like this. I'm removing this now. We are starting with from 0. Generally, we say def some. Okay, we say some add or some. I name it as some sum, and I just declare two parameters. Okay, and then b colon int. Okay, and then colon. Might be if you want to return a value, return it int. 1 minute, guys. All of you know this, right? Sorry for the interruption. And then equal today body. Now what do you do? How do you do sum? All of you know this. Just say a plus b enough for us. Okay, we are done with sum. Now call this here. You just say something like, I'll declare a variable. Let's make it more clear. The sum of 1, 2. Okay. So this is like declaring a normal function, or we can call it as regular function here. Okay. And then pass x here. Right click. Then you can say run as Scala application. And you got 3 here, right? Did you get 3? That is fine. All of you can do this. Now we are going for Lambda. The same program. I don't need to write a separate function. I don't need to do logic here. I can still optimize this. I'm going to the level to assume that this is level 1. Okay. So in level 1 we have done like this. Let's apply the same for level 2. Okay. What do you do? What is syntax of lambda? How do you define a lambda function? It's like something like this. Let me be more clear for you. I am giving syntax here. How can we define a simple lambda? You should have your parameter list here. So let me be more clear for you. Your param list followed by arrow mark followed by logic. Note this, all of you, so that next time you don't need to get confused for applying lambda. How it look like a parameter list. Parameter in sense you can have multiple parameters. All of you know how to define in the parentheses, like the variable name colon data type. So that's enough there. When you pass it to a parameter, you don't need to define var or val thing. Okay. Maybe if you ask me, is it possible to have that val or var here? We'll talk about this concept as well, because I picture in that. We'll talk on that. Okay. So that's little later, not now. Is it clear, right? So this is the syntax. What is the first part here? It should be a parameters list, or you should have a parameters. Okay. And then what is that? A rocket followed by logic. This is what it is. Now let's move this code to the level 2. I don't need a separate function to do this a simple snippet of code. Remove this. We can simplify this now. What I can do is I can do the sum. How do I do? But this time we don't have a name here. One thing you remember, we don't have a name here. But what is that? I am defining a function a colon int comma b colon int. These were my parameters. I want to find sum of 2 numbers followed by a bracket and then a plus b. Can you see this now? The same program. Earlier we have some how many lines of code? If you look at it, we have some 4 to 5 lines extra, additional lines. Okay. Now we just converted, optimized it to a single line here. And how this works here? When you look at this, these are the parameters, and this is the logic, and this is something a separator, which rocket is a separator between these two. One thing you have to remember is when you talk about lambda, remember this point, or make a note of it. Lambda will implicitly return a value. It will automatically return a value implicitly. You don't need to return anything. It will by default implicitly return a value. You get this point, right? So when you apply lambda like this, what happens? Now you are applying what is that? Addition, and then returning it, that is assigned to x now, isn't it? Then how do I call this anonymous function now? It's a challenge, right? Yes, sir. How should I call this? Now I'll do one thing. I'll just pass 1 comma 2 to this x here. This x is pointing to this lambda function, right? So now suppose earlier, let me go back to the previous point. So I have a function. I have 2 parameters to that function, and I'm implementing a logic. It is returning a value that is also assigned to x. But the question is, how do I call anonymous function? It doesn't have a name, it doesn't have anything. Then how I am going to call it? If it is a function, I can call with name. I know very well. Then this is actually something a simple question, not something difficult. When you initialize this a lambda function to some variable, this variable itself acts as a caller for us, and it also returns a value for us. So this is a name to the lambda. This itself acts as a caller, and this is itself also returns the value returned by the lambda for us. So what do you do right now? If I should call this lambda, then I should pass two values through this x, 1, 2. Let me test it. If I am going to be successful or I'm going to be a failure. Perfect. See. So level 2 is this. What did we do? This is level 2. See the optimization, how it's going on. I'm not saying I'm doing a great job here. I'm just giving you a simple idea for code optimization. But with practice, see, I don't say I'm great at optimization, but I am in the process of in that thought process. Okay, you improve yourself when you think in that direction. Got it, right? So level 2 is this. Can you see this now? Is there any optimization done so far? Did we see any difference from level 1 to level 2? Definitely we have seen that difference. There is level 3. What is that? Still, let's optimize this. So you don't need to again make this logic here. And still what you can do, you can simply apply by applying rocket, this is what works. And we have seen in the theory here, understanding rules is important, sir. Before going write a code, there is a famous quotation as well. Understand the rules and play the game. Even in programming, the toughest part is not writing the complex logic, but understanding the basic rules. But this is what many people don't concentrate. Now I have done which one? Racket part. Let me try how underscore is applied in lambda. Okay, so what do you do right now? I'm removing this logic here. I don't need this. If I'm going to apply which one? Which part, sir? If I am going to apply underscore. So this works like this. Underscore works like this. Here we are doing two things. We are passing parameters, and we are also, what is that? Remove that comma there. When you apply this process, you have to make a small change. Apply your logic with that itself. There is something I'm missing. Okay, let me. We don't need that time, that much wastage of time also. This is for okay. There is a small. So this change part here is a. What is the change part? Okay, applying underscores is fine. The way I have applied is a little bit wrong here. We should pass separate parentheses for each parameter. So this is fine for me. Okay, until this it's good. Then still it's showing error. No, it's perfect. Is it clear, right? This is level 3. What we are doing at level 3 here? We are still optimizing it. Earlier there is a logic. We have parameters and logic with a separate rocket, separated with racket. But now the same thing we optimized into a. What is that? Still that logic part is also brought into just a single this thing here. Can you see this? Still that got optimized. So what's happening here? When somebody look at this, they never think this is a function first thing. When you are very new, I'm saying, when you are a naive or when you are something beginning, and when you look at a code like this with this, there is a lambda function and it is doing addition and it is taking two parameters. That underscores are placeholders. What are these underscores here? These are placeholders, gentlemen. You understand, right? These are placeholders. Means when I, you are assigning this variable part is same. It doesn't change. But what happens now? When the calling part is also similar. See that there is no difference there. The way we call a racket lambda or underscore lambda is same. And here we do the caller. We call the caller in the same way like what we have done for racket lambda. And we just need to pass values, and these are placeholders, we can call them as placeholders. In place of this underscore and underscore, the values which we are passing to caller are going to be passed to this, the first parameter to first one and second parameter to second one, and they get substituted there, and then addition is performed. And then, so first it receives parameters, and then it will apply logic, and then finally it will return result. The basic funda doesn't change. What is that? Lambda implicitly return a value. You don't need to do that. Okay. So if you run it again, you get the same output. Can you see that thing? And if you are thinking that no, I am doing some magic here, I modified it to 10, and we are 12 here. Can you see that? There is nothing. No, we can do magic in programming. It's all about syntax. That's all. Got it right? So that's about this. Remember all these things. If you ask me a question, where exactly should we apply lambdas? Again, I will answer something to you. The best part to get a big idea about or a better idea about lambdas is just when you go to the collections. Collections demands lambdas simplicity, and we will talk more on that. Okay, we will see there how lambdas are really helpful for us. But for now, I assume you have a clear picture about different ways of applying lambdas. We have seen like the levels of understanding, like how code goes from a normal function to a racket lambda, from a racket lambda to underscore lambda. The optimization levels, how we can do that. And this is simple, but still we can do this with practice. We can take complex examples and we can apply. The point is, when lambda is preferred, whenever there is an instant logic required and where we have to implement logic in a single line, then we go for lambda. But if a code demands multiple lines, then definitely I don't think lambda is best fit. You have to write normal code itself. Okay? And these are best fit with collections. They are very useful when you are dealing with collections. Sorry, most of your parameters accepts lambdas. Very good now. Good guys, is it clear to all of you? Only Suresh is answering. What about others? Did I put you to sleep or what? I'm a little afraid. Okay. I thought this topic is very interesting, but I hope you right? No, for me, I really like this topic because there is a lot of understanding and a lot of intuition in this concept. Okay, a deeper analysis is required in this. Okay, hope all of you got this right. Test this once. Why don't you test it yourself? All the three levels. You have only one level here. You try all the three levels. Take 2 minutes time and test them. Okay, is it fine for you? Take 2 minutes time. Test it all the three levels. Then we'll. Guys, you also test this function composition. I forget to ask you to test it. So that is one more thing you have to test. I hope all of you tested this, right? This is yesterday's thing. Okay. First you complete this and also you try this function composition example. Still, if you have questions, you can ask me. And then We'll talk about the next topic. Okay, guys, there are two more topics in this, very useful. One is what is that? Multi-line expressions. That is one thing. We don't need to worry about multi-line. It's not that you know, this thing for us, but this one, function currying, something very useful for us. Okay. Code actually, because most of our code in Spark is implemented with Scala only. Okay, uses all these things, and there is a lot of advantage so far. Whatever the functional program we have done, that is going to help you a lot when you are implementing your Scala applications. More than OOP in a real-time environment, people write more of functional programming. Okay, so definitely whatever you have learned so far that help you a lot. You tested both, right? That's fine. Okay. So I would like to start the next topic tomorrow because it's already 10:30. So tomorrow I wish to finish functions, this currying topic and nested. There are a few more things. With that, we can close this topic here. We can close functions, one of the most important. Correct. So that's it today. And in last session, I mean day before yesterday, we have very good information about functions. Might be, why I insist more on this functions topic is Scala uses lot of functions while implementing logic. Not just Scala, any language use that. And Scala use functions in a different way compared to other languages. So you have to be more clear with functions so that you can understand code well and better and quickly. So that is why we are taking time to understand each and every topic clearly, slowly, perfect. Okay. There is a question asked by Bharat about F colon something. Okay. So I wish that should not be a lambda, Bharat. By I hope it looks like lambda. Yesterday, while talking about the topic, as there is a racket here, whenever we see racket, we assume it to be a lambda. But This is more for declaring a higher order function. That's what I am assuming. And the way you declare your parameters in lambda is also similar. Okay. In that way, the syntax look like that. It's similar to lambda, but I don't exactly think that we are directly implementing any lambda. But implicitly, it might be consuming some kind of lambda. I'm not sure on this. I'll update on this part. I'm not thinking this to be a lambda. Might be this should be the way where how we declare higher order functions. But let me check on that. Okay. Anyway, what we have discussed today. You got clarity on this stuff, these things, right? Function, higher order functions, and lambda functions. Are you good with these things first? Because these are most prioritized concepts. And then currying is also one more very important topic. Function currying, what we do. Currying in sense, don't think anything else. That is something related to functions here. Okay? Right. So before closing this, let me conclude what we have discussed in the last session and today's session. Higher order functions. The question is, what exactly is a higher order function and how it is useful? Means all of you know this, right? Higher order instance passing function as a parameter to another function. That is one thing. And usually, the way we declare higher order functions, syntactically it is a bit different, and we have observed that in the last session, and we have a lot of discussion on that. Second thing, coming back to the point two, how higher order functions are very useful, because when you go to the, I told you again, there are so many collection functions where they take parameters as a higher order function. Means a function as a parameter. Those functions takes function as a parameter. So, and the best fit is when you go for higher order functions, more than passing normal functions as parameters. One more important point to that: passing function as a lambda will make it more meaningful and more. It will add more richness to the code. That's what actually higher order functions accepts. That is one more important update from today's session. So we have seen how we can pass a normal function as a parameter to another function. And to the same thing, you can directly pass a lambda as a parameter itself. So we see that with some practical examples later. And then also today we have talked about a few more things. One is composition. Like, here we don't pass function as a parameter. The caller itself will be included into the another caller. And that is what we call composition. And the way we declare functions is same. We don't see something strange or different here. But for when you go for higher order, there is a slight difference. We have observed that. So that is what we have seen there. Next, coming to the lambda. What lambda does here is to be frank, it's a simple function expanded in one line, just line, one line. That's all. That is a lambda. And there are simple points here. Usually lambda takes a syntax, parameters first and then a bracket and followed by logic. Or else you can apply an underscore where logic can also be a part of the statement itself. That is one more important thing, right? And finally, one more last point about this lambda is we don't need to return any value from lambda, and lambda implicitly return a value. Got it, right? So that is another important takeaway from the lambdas. Is this clear for all of you? Right. Any more questions from anyone on this? Because I finished my dinner, I have some time, I can answer your questions. But if you don't finish your dinner, then we will stop the session. I asked the question for function composition regarding higher function. Correct. Correct. Okay. So what is your doubt there, Bharat? What you are expecting? I didn't understand. Could you please, you can talk to me, no problem, not an issue.